Oceanographic Explorations. Objectives. After attending this module, the user would be able to understand the history behind oceanographic explorations, the stages of development of oceanic investigations, and the scholars who have contributed at various stages. It will also be possible to comprehend the current trends in the science of oceanography in terms of ongoing expeditions, technological improvements, and the involvement made by various countries. Introduction. Throughout the subject of world history, sailing has been instrumental in the development of human civilization. Sailing afforded the humanity with greater mobility than travel over land. Sailing was done for trade, for transport, for warfare, and for fishing. The earliest representation of a ship under sail appeared on a painted disc found in Kuwait, dating back to the late 5th millennium BC. The first boats are presumed to have been originated from dugout canoes, developed independently by various Stone Age populations. These were used for coastal fishing and travel. Maritime History. Maritime history is the study of human activity at sea. It covers a broad thematic element of history that often uses a global approach, although national and regional histories remain predominant. As an academic subject, it often crosses the boundaries of standard disciplines, focusing on understanding humankind's various relationships to the oceans, seas, and major waterways of the globe. The concepts of nautical history records and interprets the past events involving ships, shipping, navigation, and seafarers. Many parts of their observations and understandings are taken for scientific studies or subsequent explorations and navigations. Oceanographic explorations were started way back around 4000 BC. The details available on various visible forms and oral cum written records of sailors and explorers made the subject to grow as a separate science. Ancient explorations around 4000 BC. It was during the period around 4500 BC the ocean diving habit was started by the ancient people. This was the time when coastal cultures like those seen in Greece and China began with people diving into the sea to gather food and engage themselves in commerce. In this period only, the ancient Egyptians developed their first sailing vessels. These vessels were probably used for sailing in the eastern Mediterranean Sea and near the mouth of the Nile River. It was also recorded around 1000 BC. The Greek poet Homer mentions about fishermen diving up to 30 meters by holding on to a heavy rock. First sea routes around 600 BC. In search of tin and other natural resources, the ancient Phoenicians developed typical sea routes around the Mediterranean Sea, into the Red Sea, and into the Indian Ocean. They also reached England by sailing along the western European coast. Treasure diving was continued throughout these periods. Diving for treasure created many wars between the Persians and the Greeks. Around 414 BC, the diving was used in warfare. The Greek historian Thucydides writes about diving used in warfare in his narration of the siege of Syracuse. First crude diving bell design. It was around 360 BC. The Greek philosopher Aristotle mentions about the use of a sort of crude air supply diving bell. Aristotle wrote that one can allow divers to breathe by lowering a bronze tank into the water. Naturally, the container is not filled with water but air, which constantly assists the submerged man. It was around 325 BC the first use of a diving bell was observed. Alexander the Great made use of a crude diving bell to employ combat divers during the siege of Tyre. The diving bell contained colored glass so that the divers could see through it. The divers used the bell to clear debris from the harbor. Alexander himself made several dives with the device to check on the progress of the work. The Voyage of Pythias. It was around 325 BC. The Greek astronomer and geographer Pythias sailed towards north from the Mediterranean. He reached the coast of England. He was the first person on record who described about the land of midnight sun and the north of the Arctic Circle. He also developed methods for using the sun and the North Star to determine the location of latitudes. Circumference of the Earth discovered. Around 200 BC, the Greek astronomer Eratosthenes became the first person to determine the circumference of the Earth. It was a breakthrough in the history of geography. He used the angles of shadows and the distance between Alexandria and Syene to arrive at a value of 40,000 kilometers. The actual circumference of the Earth was found to be 40,032 kilometers. The world's all geographic, earth and atmospheric sciences got a turning point after these observations. Ptolemy's map of the world. In the year 150 BC, the Greek astronomer and geographer Ptolemy produced the first map of the ancient world. It was showing the distribution of continents of Europe, Asia, and Africa, as well as the surrounding oceans. This early map was one of the first known maps developed to include the lines of latitude and longitude. Around the year 100 BC, salvage diving operations were continued around the major shipping ports of the eastern Mediterranean. It was around 200 AD, the first indicated use of goggles were found from the artworks of Peruvian pottery. They have shown the divers wearing goggles and holding the fish with them. Fishery was an important occupation of people from time immemorial. Viking expeditions and voyage of Leif Erikson. It was around 900 AD the Vikings began to explore and colonize the Iceland, Greenland, and Newfoundland. They were among the first groups to use the North Star to determine their latitude. In the year 1002, Norse explorer Leif Erikson became the first European to land in the North America. His voyage took place almost 500 years before that of Christopher Columbus. He called the new land as Vinland and established a Norse settlement in what is now seen in the northern tip of Newfoundland in Canada. This paved the way for oceanographic explorations for territorial ownership at a later stage. Chinese exploration. Chinese exploration includes exploratory Chinese travels abroad, on land and by sea, from the 2nd century BC until the 15th century. Before the advent of the Chinese invented mariner's compass in the 11th century, the seasonal monsoon winds controlled Chinese navigation. In the year 1405, the Chinese made 7 voyages consisting of over 300 ships with a combined crew of nearly 37,000. These voyages were designed to extend the Chinese influence and impress their neighboring states. Their economic pressures back home made them put an end to these expensive voyages of the Chinese. Indian Ocean and beyond. Chinese envoys sailed into the Indian Ocean in the late 2nd century BC. They reportedly reached Kanchipuram, known as Huangzi, to them. During the late 4th and early 5th centuries, Chinese pilgrims like Faxian, Xian, and Tanwuji began traveling by sea to India, bringing back Buddhist scriptures and sutras to China. By the 7th century, as many as 31 recorded Chinese monks, including I Ching, managed to reach India the same way. In 674, the private explorer Daxi Hongtong was among the first to end his journey at the southern tip of the Arabian Peninsula, after traveling through 36 countries west of the South China Sea. Chinese seafaring merchants and diplomats of the medieval Tang dynasty, 618 to 907, and Song dynasty, 960 to 1279, often sailed into the Indian Ocean after visiting ports in Southeast Asia. Chinese sailors would travel to Malaya, India, Sri Lanka, into the Persian Gulf. Voyages of Columbus and Vasco da Gama. The Spanish explorer Christopher Columbus sets out on his historic voyage across the Atlantic Ocean in search of a passage to China and India in the year 1492. Instead, he discovered the North and South America, which eventually led to the establishment of European colonization in these newly discovered continents. Similarly, in the year 1498, the voyage of Vasco da Gama made some unique findings. The Portuguese explorer Vasco da Gama sailed his ships around the Cape of Good Hope, located on the southern tip of Africa. He became the first European to reach India by boat. The expedition later returned to Portugal with a huge, valuable cargo of rare spices and valuables. This has opened a new dimension in oceanographic explorations. First circumnavigations of the world. In the year 1519, Ferdinand Magellan and his fleet departed from Portugal to start a daring voyage of discovery in history. The fleet became the first to sail around the whole world. Magellan's expedition of 1519 to 1522 became the first expedition to sail from the Atlantic Ocean into the Pacific Ocean. The Magellanic penguin was named after him, as he was the first European to note it. In March 1505, at the age of 25, Magellan enlisted in the fleet of 22 ships sent to host D. Francisco de Almeida as the first viceroy of Portuguese India. Although his name does not appear in the chronicles, it is known that he remained there 8 years in Goa, Cochin, and Quilon. He participated in several battles, including the Battle of Kannanur in 1506, where he was wounded. In 1509, he fought in the Battle of Diu, but unfortunately, Magellan could not live to see the entire accomplishment. He died on the island of Mactan in the Philippines in 1521 from the poison arrows sent by the local natives. First plans for a submarine. An English mathematician named William Bourne drew up the first known plans for an underwater boat in the year 1578. These plans called for a leather-covered wooden frame craft that would be rowed from the inside. Later, in the year 1620, the first submarine was made. Dutch physician Cornelis Drebbel built the world's first submarine. The boat was made of wood reinforced with iron and covered with leather. It was a 12-seater submarine in 2 rows inside. They rowed with oars that stick out the sides through tight-fitting leather sleeves to keep the water out. Drebbel made several trips in his submarine in the Thames River near London at a depth of about 4 to 5 meters. Voyage of Edmund Halley. In 1690, the first air-replenished diving bell was made. The English astronomer Edmund Halley developed a diving bell in which the atmosphere in the bell can be replenished by sending weighted barrels of air down from the surface. In 1698, Edmund Halley made what was called as the first scientific voyage to study the variation of the magnetic compass. During his voyages, he also made very important contributions to the understanding of the trade winds. Waterproof suit and diving devices. In the year 1715, the first waterproof suit was made. Cavalier de Bouvet, a guard in the French Navy, developed a waterproof suit with lead shoes. Air gets supplied from the surface by two leather tubes fastened to the helmet. In 1715, the first enclosed diving device was made. It was Englishman John Lethbridge who developed a completely enclosed one-man diving dress. The device was made from a reinforced leather-covered barrel of air, equipped with a glass porthole for viewing and two armholes with watertight sleeves. The first voyage of the Endeavour. It was in 1768, Lieutenant James Cook left the port of Plymouth, England, on a voyage to observe a transit of the planet of Venus across the sun. During this and other two voyages, he could explore and map the Pacific Ocean. He was the first person to use a chronometer to accurately determine his longitude at sea surface. In the year 1785, the American patriot and inventor Benjamin Franklin writes a lengthy letter to a scientific colleague in France, known as his Sundry Maritime Observations. The letter announces the discovery of the Gulf of Stream and touches on a wide range of maritime subjects such as ship propulsion methods, hull design, and causes of disasters at sea. The Nautilus. In the year 1800, Robert Fulton, the inventor of the steamboat, built an early submarine called the Nautilus. This cigar-shaped craft was made of wood over iron plates and used a horizontal rudder to control the up and down movement of the submarine. The system is still in use even today. President Thomas Jefferson signs a law establishing the United States Coast Survey in 1807. The voyage of the H.M.S. Beagle. In the year 1831, the English naturalist Charles Darwin departed England aboard in the H.M.S. Beagle. The goal of the expedition was to perform a survey of Patagonia and Tierra del Fuego. Darwin studied the plants and animals at each new stop. He discovered many unique species on the Galapagos Islands off the coast of Peru in South America. These discoveries led to his groundbreaking theory of evolution. In his book, The Origin of Species, Darwin suggested that the deep ocean may be a sanctuary for living fossils. In the year 1840, the first modern sounding was done. Sir James Clark Ross conducted the first open ocean deep water sounding in 2,425 fathoms in the South Atlantic Ocean at a latitude 27 south, longitude 17 west. The sounding was made using the traditional method of lowering a hemp rope over the side of the ship. Observations of early 19th century. In 1842, Charles Darwin publishes The Structure and Distribution of Coral Reefs. In the year 1843, British naturalist Edward Forbes stated about his belief that the life cannot exist below 300 fathoms or 1,800 feet in the deep sea. This declaration made a 20-year debate about the possible existence of a lifeless zone in the ocean known as Azoic Zone. In the year 1849, Coast Survey soundings in support of Gulf Stream investigations resulted in the discovery of the continental shelf break, and the continental slope. In 1853, Louis F. D. Portales of the U.S. Coast Survey found indications of life in depths over 1,000 fathoms or 6,000 feet inside the deep sea. In 1857, the first deep-sea canyon was discovered by James Alden, a commanding officer of the Coast Survey streamer active in the center of the Monterey Bay, off the coast of California. It is now known as the Monterey Canyon. In 1860, the first chart of the Gulf Stream was published by the U.S. Coast Survey. In 1861, the first U.S. Navy submarine, known as the Alligator, was designed and used. Observations of the late 19th century. In 1872, the most popular voyage of the H.M.S. Challenger happened. The H.M.S. Challenger sailed from Portsmouth, England, and began its 4-year trip around the world. During the voyage, scientists tested the salinity, temperature, and density of the seawater. Information was also collected about the ocean currents, sediment, and meteorology. The crew discovered underwater mountain chains and hundreds of species previously unknown. This research was eventually consolidated into a 50-volume research report known as the Challenger Report. This research formed the basis of modern oceanography. Other developments. In 1874, the Zigbee sounding machine was invented. This new machine became the basic model for wireline sounding in the deep sea for about 50 years. In 1882, the first oceanographic research vessel, Albatross, was sailed. In 1888, the first modern electric submarine, Gymnote, was designed by the French Navy. This steel-hulled craft was powered by a 204-cell battery. The Marine Survey of the Pacific, made in 1899 by the Swiss zoologist Alexander Agassiz, was yet another milestone. In 1912, the Scripps Institute of Oceanography became affiliated with the University of California. The Scripps is one of the world's leading marine research centers today. In 1914, the first acoustic exploration of the seafloor was attempted by the Canadian inventor Reginald Fessenden. The Titanic episode. On the 15th April 1912, the White Star liner Titanic sunk after striking an iceberg in the North Atlantic Ocean. Over 1,500 passengers lost their lives during one of the worst peacetime maritime disasters in the history of mankind. This tragedy led to a concerted effort to devise an acoustic means of discovering the objects in the underwater zone well ahead of a moving vessel. In 1985, Dr. Robert Ballard, with the help of a tiny robotic submarine named Jason, discovered the wreck of the Titanic. The wreck was found in 3,850 meters of water column at about 500 kilometers off the coast of Newfoundland in Canada. Titanic was found in 2 separate pieces. Mapping the ocean floor. In 1925, the German vessel Meteor sailed around the Atlantic Ocean and took detailed measurement of the ocean floor using modern echo-sounding equipment. These voyages revealed new information about the shape and structure of the ocean floor. Subsequently, in 1935, the researchers at the Coast and Geodetic Survey invented an automatic telemetering radio sonobuoy. This instrument was considered to be the first offshore-moored telemetering instrument. In the year 1937, geophysicist and oceanographer Athelstan Spilhaus invented the first bathythermograph. It was a good measuring device that can continuously record the ocean water temperature. This was a remarkable development in oceanography at that time. The World War II research. In 1941, during World War II, the electronic navigation systems were developed for precision bombing. A few years later, the Coast and Geodetic Survey conducted its first hydrographic survey using these systems. Research during the war led to many new tools for ocean exploration, including deep ocean camera systems, early magnetometers, side-scan sonar instruments, and early technology for guiding remotely operated vehicles, ROVs. This was a turning point in all modern oceanographic explorations. In 1943, the Aqualung, the first modern scuba system, was designed. In 1951, the British ship Challenger 2 bounced the sound waves off the ocean bottom and located the sea's deepest point. It was subsequently named as the Challenger Deep. Discovery of Mid-Atlantic Ridge. It was in 1953 the American geologist Mary Tharp studied the sounding profiles from the Atlantic Ocean and discovered a rift valley. Later studies revealed that it is a continuous rift valley extending over 40,000 nautical miles along the ocean floor. This discovery provided the most useful evidences for the newly formed theory of continental drift, known today as plate tectonics. Later, in 1961, the Scripps Institution of Oceanography developed the Deep Tow system. This sonar system became the forerunner of all remotely operated and unmanned oceanographic systems, which is used even today. In 1963, the first operational multi-beam sounding system was installed on the USNS Compass Island. Robotic submersibles. Alvin, a new deep submergence vehicle, was constructed in 1964 by the Woods Hole Oceanographic Institute. It was the first U.S. deep diving submersible and the first deep sea submersible capable of carrying passengers. In 1965, the first underwater robotic submarine, Halibut, which can lower miles of lengths of its cables bearing lights, cameras, and other gear to spy on enemy armaments and find the other materials that were once lost on the bottom of the sea. Deep Sea Drilling Program. In 1968, the deep sea research vessel Glomar Challenger departed on a 15-year expedition known as the Deep Sea Drilling Program. The ship crisscrossed the entire mid-Atlantic ridge between Africa and South America and took a lot of core samples. The ages of the samples provided solid evidences for the theory of seafloor spreading, which later gave rise to the modern theory of plate tectonics. In 1969, the first long-duration submersible expedition was made off the coast of Palm Beach, Florida. Hydrothermal vents were discovered in 1977. Deep Sea Submersible, Alvin. In 1977, the Deep Sea Submersible Alvin was sent to explore a part of the mid-ocean ridge north of the Galapagos Islands known as the Galapagos Rift. Alvin was following in the tracks of an unmanned vehicle towed by the research vessel Nor that had detected unusually high bottom water temperatures and had taken photographs of odd white objects among the underwater lava flows, tantalizing clues about curious, possibly biological features. Argo Project. In 1990, a program known as Argo was started by deploying 3,000 robotic probes throughout the world's oceans to monitor the climate, weather, and sea surface height. It was named after the mythical ship from the story of Jason and the Argonauts. The last probes were successfully placed in 2007. In 1993, the undersea laboratory, Aquarius, began its operation off the coast of Key Largo, Florida. Seafloor Mapping from Space. The worldwide mapping of the seafloor from space was done in 1995. In 2010, the census of marine life was completed. This 10-year project involved 2,700 scientists from 80 nations. The census revealed what, where, and how much lives and hides were there in the global oceans. The data is made available in the online directory that allows anyone to map the global addresses of species today. In 2012, a Japanese expedition and film crew captured the first video of a live giant squid in its natural environment. Modern trends in oceanography. Citizens, sailors, and scientists have observed the seas and oceans for several hundred years. First from the shore, then from ships and submersibles, and recently from satellites. While carrying out these explorations, scientists and engineers learned that they could sometimes leave some sophisticated instruments in the ocean, secured by wires, buoys, weights, and floats, and allow them to systematically map the ocean floors. This method is known as the moored observatory. This approach has advanced the understanding of the oceans and their interaction with the Earth and the atmosphere. Underwater vehicles. In order to understand the ocean, scientists often find that they have to get themselves or their instruments into very specific parts of it. Traditionally, researchers have used ships to photograph the depths. They used to drop floats and drifters into the currents and to collect samples of water, rock, and marine life for their analysis. In recent years, the spectrum of available observing tools has grown to include human-occupied submersibles, remote-controlled vehicles, autonomous and towed robots. Earth's first artificial satellite. In the year 1957, the Soviet Union successfully launched its satellite Sputnik 1. It was the world's first artificial satellite. About the size of a basketball and weighing only 183 pounds, Sputnik took about 98 minutes to orbit the Earth. This was the Earth's first artificial satellite, which ushered in an age of exploration not only of space, but of the Earth's land masses and oceans as well. Satellites that detect and observe different characteristics and features of the Earth's atmosphere, lands and oceans are often referred to as environmental satellites. Polar Operational Environmental Satellites, POES. Polar Operational Environmental Satellites maintain an orbital height of about 500 miles and take about 100 minutes to complete an orbit. Sea surface temperature is one important type of data that these satellites provide. Knowing the temperature of ocean water is an important aspect in oceanography. Temperature changes influence the behavior of fish. It can cause the bleaching of corals and affects the weather all along the coast. Satellite images of sea surface temperature also show patterns of water circulation. Mapping ocean surface indicators. In addition to temperature, satellites also provide information about the color of the ocean. This allows scientists to detect the presence of algal blooms, river plumes, and other events. Satellite imagery is also being used to map features in the water, such as coral reefs. Sensors such as Landsat 7 and IIOE provide detailed information on local areas. Landsat 7 is part of the Landsat Program, one of the longest existing environmental satellite programs. Satellites providing environmental imagery are used jointly with other organizations that receive data from various sensors. For example, marine animals such as sea turtles and manatees can be fitted with transmitters that relay information about their location. Satellites are becoming a standard tool for studying the oceans. Background of the CYFS project. The purpose of the Sea Viewing Wide Field of the View Sensor CYFS project is to provide quantitative data on global ocean biooptical properties to the Earth science community. Subtle changes in ocean color, signify various types and quantities of marine phytoplankton, microscopic marine plants, the knowledge of which has both scientific and practical applications. The CYFS project will develop and operate a research data system that will process, calibrate, validate, archive and distribute data received from an Earth-orbiting ocean color sensor. Ocean color reflecting marine biota. The concentration of microscopic marine plants, called phytoplankton, can be derived from satellite observation and quantification of ocean color. This is due to the fact that the color in most of the world's oceans in the visible light region, wavelengths of 400 to 700 nautical miles, varies with the concentration of chlorophyll and other plant pigments present in the water. That is, the more phytoplankton present, the greater the concentration of plant pigments and the greener seawater. Since an orbiting sensor can view every square kilometer of cloud-free ocean every 48 hours, satellite-acquired ocean color data constitute a valuable tool for determining the abundance of ocean biota on a global scale and can be used to assess the ocean's role in the global carbon cycle and the exchange of other critical elements and gases between the atmosphere and the ocean. Geostationary Operational Environmental Satellites, GOES. GOES satellites provide the kind of continuous monitoring necessary for intensive data analysis. Because GOES satellites stay above a fixed spot on the surface, they provide a constant vigil for the atmospheric triggers for severe weather conditions such as tornadoes, flash floods, hailstorms, and hurricanes. When these conditions develop, the GOES satellites are able to monitor storm development and track their movements. GOES satellite imagery is also used to estimate rainfall during the thunderstorms and hurricanes, for flash flood warnings, as well as estimates snowfall accumulations and overall extent of snow cover. Such data help meteorologists issue winter storm warnings and spring snow melt advisories. Satellite sensors also detect ice fields and map the movements of sea and lake ice. The Landsat Program. The Landsat Program provides the longest continuous space-based record of Earth's land in existence. Since 1972, Landsat satellites have collected measurements of Earth's continents and surrounding coastal regions that have enabled people to study forests, food production, water and land use, ecosystems, geology, and more. The long data record allows scientists to evaluate the dynamic changes caused by both natural processes and human practices. The Landsat program is jointly managed by the US Geological Survey and NASA. Every day, Landsat satellites provide essential information for land managers and policymakers to support wise decisions about our resources and environment in the places we live and work. Global ocean biomes. The large ocean ecosystems are called as biogeographic provinces. Biogeographic provinces provide useful categories for comparing and contrasting important ocean processes such as primary production, carbon flux, and species distribution and diversity. Climatological provinces have been identified using a prior expert knowledge. The global remote sensing data automatically produce the time and space resolved province distributions. Today, 3D mapping of ocean water masses and biomes are being done in oceanographic analysis. Satellite oceanographic products provide an unequaled view of the global ocean surface, allowing us the opportunity to map important biogeochemical processes in the ocean, such as primary production and carbon export to the deep ocean. Ocean exploration and human health. At least 20,000 new biochemical substances from marine plants and animals have been identified during the past 30 years, many with unique properties useful in fighting disease. Biodiscovery researchers have had success in all types of ocean environments. A 1991 expedition by the Scripps Institution of Oceanography's Paul Jensen and William Fennicull resulted in the discovery of a new marine bacterium, Salinispora tropica, found in the shallow waters of the Bahamas. This bacterium produces compounds that are being developed as anti-cancer agents and antibiotics. It is related to the land-based Streptomyces genus, the source of more than half of our current suite of antibiotics. Metagenomics. Researchers are now looking at the ocean through a new lens, the science of metagenomics. In the ocean, as on land, thousands of species of tiny microbes play a key role in nutrient cycles, including the carbon cycle, and in maintaining Earth's atmosphere, among other important functions. Metagenomics enables researchers to quickly sequence the DNA of all microbes in a given sample, in this case seawater, revealing how microbes function and how they may work in different environments. After mapping 64 million base pairs, units of DNA, thousands of new genes, and also variations in the genetic composition of microbes at different depths were also discovered. Genomes from organisms in the deep ocean had many jumping genes or pieces of DNA that can move from one part of the genome to another. Human-occupied submersibles. Two other U.S. academic and research organizations operate human-occupied submersibles. The University of Hawaii has two PCs submersibles capable of diving to 2,000 meters or 1.2 miles, and Harbor Branch Oceanographic Institution in Florida has two Johnson Sealing submersibles that can dive to approximately 1,000 meters or 0.6 miles. France and Russia operate HOVs that can dive to a depth of 6,000 meters or 3.7 miles, and Japan's Shinkai 6,500 is able to dive down 6,500 meters or 4.0 miles. China is building an HOV that will be able to dive to 7,000 meters or 4.3 miles. Autonomous Benthic Explorer. The Autonomous Benthic Explorer, more commonly known as ABE, is the first underwater robotic vehicle of its kind. ABE was designed and built at the Woods Hole Oceanographic Institution, WHOI, in the mid-1990s. ABE weighs approximately 1,200 pounds and is a little over 2 meters long. ABE's top cruising speed is 2 knots. As an autonomous underwater vehicle, AUV, ABE is a true robot, able to move on its own without a pilot or tether to either ship or submersible. This gives ABE the advantage of covering large areas of underwater terrain. ABE was invented to address scientists' frequent need to monitor underwater areas over long periods of time. ABE is designed to perform a predetermined set of maneuvers, take photographs, and collect data and samples within an area about the size of a city block. After accomplishing its mission, ABE goes to sleep, conserving its power supply for months at a time, allowing for future missions without recharging its batteries. Satellite communications. Although ships have been crisscrossing the ocean for centuries, Earth observations from satellites provided the first truly global view of the ocean and its processes. Recent improvements in satellite communications on ships are fundamentally changing the nature of seagoing science. Many oceanographic ships now have internet connections through a network known as High Seas Net. With this network, Shipboard scientists can work in real time with their land-based colleagues. International Indian Ocean Expedition, IIOE. The International Indian Ocean Expedition, IIOE, resulted from a cascade of effects. The International Geophysical Year of 1957-1958 had shown the value of coordinated multinational efforts in ocean science. This realization resulted in the International Council of Scientific Unions, now the International Council for Science, creating the Scientific Committee on Oceanic Research, SCOR, to continue to stimulate international cooperation in ocean sciences. The International Indian Ocean Expedition, IIOE, was one of the greatest international interdisciplinary oceanographic research efforts. It involved 46 research vessels under 14 different flags that carried out an unprecedented number of hydrographic surveys and repeat surveys of the entire Indian Ocean basin from 1960 to 1965. Emergence of Innovations. In the last 50 years, since the formation of IIOE, there have been two fundamental developments in ocean science. The first one is the emergence of new components of the ocean observing system, most notably remote sensing and ergo floats. The second one is the emergence of ocean modeling in all its facets, including short-term forecasting, seasonal predictions, and climate projections. These developments have revolutionized our understanding of the global oceans. Ocean exploration continues to illuminate details about Earth processes. Ocean altimetry. Spaceborne radar altimeters are superb tools for mapping the ocean surface topography, the hills and valleys of the sea surface. These instruments send a microwave pulse to the ocean surface and determine the time taken by the waves to return. A microwave radiometer corrects any delay that may be caused by water vapor in the atmosphere. Combining these data with the precise location of the spacecraft makes it possible to determine the sea surface height very accurately. The strength and shape of the returning signal also provides information on the wind speed and height of ocean waves. These data are used in ocean models to calculate the speed and direction of ocean currents and the amount and location of heat stored in the ocean, which in turn reveals the global climatic variations. Ocean Surface Topography Mission. The Ocean Surface Topography Mission, OSTM, on the JASON-2 satellite is an international Earth observation satellite mission that continues the measurement of sea surface height, which was started in the year 1992. It was followed by the NASA CNES JASON-1 mission, launched in the year 2001. The two previous altimetry missions, TOPIX, Poseidon and JASON-1, have led to major advances in the science of physical oceanography and in climate studies. Their 15-year record of ocean surface topographic data has provided the first opportunity to observe and understand the global change of ocean circulation and sea level. The results have improved the understanding of the role of the ocean in climate change and improved both weather and climate predictions. Conclusion. Oceanographic exploration and maritime history are the two broad overarching subjects. They include the aspects like fishing, whaling, international maritime law, naval history, the history of ships, ship design, shipbuilding, the history of navigation, the history of the various maritime-related sciences, oceanography, cartography, hydrography, etc., sea exploration, maritime economics and trade, shipping, yachting, seaside resorts, the history of lighthouses and aids to navigation, maritime themes in literature, maritime themes in art, the social history of sailors and passengers and sea-related communities. Jean-Wes Costume, an oceanographer, said, "The future is in the hands of those who explore, and from all the beauty they discover while crossing perpetually receding frontiers, they develop for nature and for humankind an infinite love." Oceanographic explorations continue even today in the form of underwater surveys, expeditions, and mission for sustainable development.